Hello, this is lesson number 18 for our course of building prediction dashboard for stock prices with Python and Streamlit. To remind you, we are in train predict py file, and last session we stopped after creating prepare features. And the next one is prepare prediction features. A couple of notes about this file. This method will prepare a single feature vector that represents the previous trading days, so the model can predict tomorrow's closing price. Constraint is that at prediction time, today's closure price does not exist yet. So this one should be designed carefully to avoid the data leakage. Let's start our coding with one note declaration of what this method does. Prepare features for prediction using only the historical data. I should add one more line here. This is excluding the current day. And let's start. Red df equals data frame alloc -2 to -1, copy. This line here, right, this one uses the day before current. So this selects from the data frame only one row, the second to last day. df ilog -1 will be today, df ilog -2 yesterday. Why not the df ilog -1? Because today's close is unknown at the prediction time, and using it will leak the future information. And why we are slicing it -2 to -1? Because -2 and -1 will return a data frame, not series, and we want to avoid using series. This preserves column structure and allows to our next steps, and we are using copy to avoid risk of the silent bugs, and pandas actually may not assign values later. So that's the whole reason of this line at the start of the code. Now, after this, we will start technical indicator calculation. Prediction data frame for SMA 5 will be data frame close rolling window 5 mean and ilog with -2. Let's go quickly over this one too, because the next couple of lines will be the same, and I will just roll this one into roll this one into details to avoid going again after all the next lines of code. What's happening with this line of code? SMA is computed over the entire historical series, and the value of the yesterday, as of yesterday, is extracted. So we again, leaving aside current day because we don't have closure prices yet, and use that rolling SMA as our metric of 5 days. Why not compute the rolling of prediction df? Because prediction df contains only one row, so rolling would return NaN. And why ilog -2? To ensure that only the data up to yesterday appears and no future prices are included. The next few lines will be basically repeating of this one. So I will just tabulate it. SMA 20 will be the closure price for rolling window equal to 20, and again mean values, and ilog up to -2. The same goes for RSI. Calculate RSI for up to -2, price change and volume change. Next, we are going over the lag features. You remember we had the same in a previous method, lag features here. What we are doing with it, basically we will use the similar approach. We are creating a temporary memory for non-sequential models. This means from 1 to 6, close lag 1 will be yesterday's close lag 2 will be the day before yesterday, etc. So let's have the code for it too. For E in range 1 to 6, let's have here naming features. Prediction df close lag E equals df close for ilog. Let's show this part. It will be equal to ilog -2 minus E if length of df is more than I plus 1, or else df close ilog -1. And the same will go for the volume lag. Red df volume lag will be just the same. Let's walk through it a bit more. This line here, prediction df close lag -2 minus E, we start with 2 as yesterday, -2 as yesterday, -3, the next one will be 2 days ago, and this will serve to our alignment. And why we are using the if else block here, because we are protecting against edge cases to prevent index error, etc. This is not perfect statistically, but it rather plays safe in our case. Same, of course, goes with the volume lag. And next we will go over here and go with feature orders. Let's add one line here, feature columns. Our feature columns will include open, close, high, low. Close, make sure close is not needed here. Open, high, low, SMA 50 and SMA 20. Let's leave these three away. And plus f string close lag I for in range 1 to 6 and f close f volume lag I for e in range 1 to 6 again. Let's talk a bit about these feature columns. Why we are doing this? Because the ML models will expect exact same feature order, same number of columns and same semantics. If order changes, it will make predictions to silent garbage. Now let's form this to return the format that is expected. We will not going to return this, of course. X prediction equals predict feature columns values, and return will be X predict. This line here will return a shape of 1 to n features, exactly what the sklearn expect. And the return of it will be what we are providing for sklearn, the shape of from 1 to n features. What does this method do? This prevents data leakage, enforces temporal correctness, and produces model safe input. This is all for this session. Next, we are going to work on calculate RSI, and after that we will start with training our models. It will be random forest. Next will be train linear regression. After this we will train ARIMA. Don't pay attention to these arguments, we will go over them later on, one by one. Def train RNN. Or even let's stop here. this should be enough for our upcoming session. We will continue work on these 4 methods, and after that we will go through the RNN and LSTM models. Thank you for your time, and see you at the next session.